Discussion section, 1 to 2 p.m. Wednesday, Fridays. Go to whichever one you want. Starting next week, don't do that this week, it'll confuse everyone. So starting next week, just try to pop into one of them to take the quiz that will happen. I think it's usually in the first 5 minutes, and then if you don't like discussions, feel free to leave like right after that. Let's see, anything else I need to state? Do you guys have questions about course logistics or anything about the way things are run? Yeah, or no, yes, no? Go ahead.
Yeah, so is it 2 quizzes a week during each discussion?
I think so. Yeah, not today, obviously. And I think the quizzes are supposed to be like piss easy. Like they're not supposed to be hard in any way. I think if you were paying attention, like even somewhat in discussion, you should be fine. It's more of like a sanity check where it's like, if you see this and you're like, I don't know how to do this, like alarm, like you need to study because stuff builds off each other. And also, I hate homework, so we sort of decided we're gonna trial this quiz format, see how it goes. Yeah, problems with homeworks are that some of them are just annoyingly tedious, and then the value you gain out of them after a certain point is just diminished. So let's see how this goes. This could be a total disaster. We'll see. Any other logistical questions? No? Yes? Okay, let's get started. So typically when we think about problems, if someone asks you in an interview to write a LeetCode solution to a problem, I hope you do it in Python and not C++ first, because if I was the interviewer, I would hate reading your C++ code. But second of all, you have a function with variable output types. You may have something where it's like, I don't know, find the longest path that does X, Y, Z. Is this string a palindrome in which you would return a Boolean value? Or you may have something a bit more complicated where you have multiple return types. You return an integer and a list. I want to shift the perspective of return types to everything is a Boolean value. So let's say I ask you to find the longest path in a graph, and the longest path goes from S to A to B to C to D. That would be the output of your function. Instead of doing that, I could write another function that says, is this the longest path in the graph? So I give you A, B, C, D, and I ask you to return true or false. So I want to convert every single problem into a Boolean decision problem where the output is 0 or 1. And usually that conversion is trivial. So I want to take any arbitrary function output type and return it as a Boolean value instead of whatever the output type is. So example, let's just say def get primes. I take in an integer k, and the output is the first k prime numbers. Okay, so this is actually bad because I don't know how to generate primes. So let's make the output the first 5 prime numbers. Okay, 1 a prime number. Yeah. 3, 5, 7, 9. All right, so I return this. Shut the fuck up. Just kidding. Just joking. This is equivalent to asking. So this is equivalent. I can write a function r first primes, first 5 primes, which takes in a list A, and then it checks, is A equal to the list 1, 3, 5, 7, 9. So return true if A is equal to this, return false otherwise. The reason this is important is because now I can take these functions and put them into sets. I can convert the decision problem about whether or not these are the first 5 prime numbers, whether or not the answer is true or false, whether or not the answer is 0 or 1, into a set membership problem where the element lies in the set if the answer is true, and the element doesn't lie in the set if the answer is false. So let's start with the first problem. So I want to do a shift from, I want to make a shift in paradigm and say that problems are just sets. Sorry, that is completely wrong. Languages are sets. And problem instances are elements of the set. So let's take a simple example. So let's say you have problem 1 on the lab, by the way. The question says, you're trying to formulate the problem, you're given a binary number, and you want to output if it's divisible by 4. So how would we solve this problem, first of all? Someone gives you a binary number, you want to know if it's divisible by 4. Forget set theory, forget everything you learned in lecture yesterday if you went. How do I know if a binary number is divisible by 4?
If the remainder is 0 when you divide by 4.
If the remainder numbers divide, okay, great. So that if I give it to you in an integer, that's very easy to check, right? You do I mod 4 equals 0. What about the binary representation of a number? Yeah.
If like the third last digit or any one to the left of it is 1, then
It's not, right? Okay, so the third to last digit of the binary representation, let's see, 0, 1, 1, going this way? Is what you're saying?
like third last digit, last digit, last digit, any of those are 1. Like,
How many do you want to go back? 3 or 4 or 2 or 1?
like third last,
Here,
yeah, this one and to the left of that.
to the left of that. Okay, so
It's like 1, that's to the power 0 to the power 1 to the power
right,
2.
right. So this is what? 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4, etc., etc. So what we see is another way of looking at this is what's the smallest binary number divisible by 4? Well, 100 is definitely divisible by 4. What's the next largest number divisible by 4 that I can make in binary? Oh yeah, this is 4. What's the next biggest number that's divisible by 4 in integer space? Great. And what is that in binary? 1, 0, 0, 0. Correct? Okay, great.
I think that was
The
already.
above one.
Okay, that's why I got blank stares. Okay, and then the next number that's divisible by 4 is 12. How do I make 12? I set these two to be 1 each. So the last two, yeah, these two to be 1 and the last two to be 0. Okay, how do I make 16?
Add another 1 to the left.
Where? Here? Yes.
1 and then 4 zeros.
Great. Okay, so what do we notice about all these numbers, pattern-wise? Okay, let's do this. What happens in binary? Let's say you have a binary number. How do you divide it by 2? In C. Right, so you bit shift it to the right and bit shift it to the left, right? So if you were to divide a number by 4, you would bit shift 2 bits to the right and then 2 bits to the left to get, you would zero out the last 2 bits. So if we focus on the last 2 bits, if you focus on this pattern, the last 2 digits of every binary number divisible by 4 is 0, 0. So simply, if I asked you for binary numbers divisible by 2, only the last bit would need to be 0. Okay. Okay, so I have this problem. Are binary numbers, is the given binary number divisible by 4? And in order to solve it, I inspect the last 2 bits and let you know if it's possible. So one way, as I said, is we write normal Python code to inspect the last 2 bits, or we can represent the language as a set. So ldiv4, and I want this set to be only numbers that are divisible by 4. So one way of describing this is x 0, 0, such that x is a binary string. Does that make sense? So now, only things that end with 0, 0 are in the set, and things that end with 0, 1, and things that don't end with 0, 0 are not in the set. So this is one approach to mapping yes instances. What's another way I could represent this problem as a set? So one encoding that I said is, you have a problem, the answer is yes or no. If the answer is yes, I put it in the set. If the answer is no, it's not in the set. Can we think of other ways of encoding problems in sets? So again, you have a problem that's always going to be true or false. You want to convey to somebody else whether or not the answer is yes or no. Can you think of an encoding scheme that would allow you to do that?
1 and 0.
1 and 0. Okay, so how would that work? How would
1 would be true or yes, and 0 would be false or no.
Great. So one thing you could do is I could make a set. So this is approach 1. Approach 2 is I have LDiv 4. And then what I could do is I could actually just list every single number and append yes or no to the answer. So I could append, let's say 0 is divisible by 4, so the answer is yes. 1 is not divisible by 4, so the answer is no. 2 is not divisible by 4, so the answer is no. 3 is not divisible by 4, so the answer is no, etc., etc. So I could also just give you the infinite set and then just append yes or no if each individual integer is in the set or not. So 2 approaches. Set membership equals yes, lack of set membership equals no, or explicitly construct every element in the set. If the answer is yes, append yes. If the answer is no, append no. Questions about these strategies? Does anyone actually understand anything that's happening? Okay, cool. Let's move on to the second problem. The sum of 2 unary integers. The sum of 2 unary integers. So unary means all ones. So 1, 1, 1, 1 plus 1, 1, 1, 1. If you add it, you're just going to get 7 ones. 1, 2, 3, 4, 5, 6, 7. So in general, when you add in a unary system, when you add just ones, it's basically concatenation. There's nothing special about this. So if I have 1 to the I, and then I have 1 to the j, what should the sum be?
1 to the I plus j.
Yep, great. 1 to the I plus j. So now I know how to check if a number is unary or not. I want to now represent this as a set or a language. Languages are sets. Problem instances are members in the set. So what is the input? 2 unary integers. So let's say L unary So in general, I like putting the inputs on the left and the outputs on the right. But, well, no, the inputs on the left are the form of the input. So what am I expecting as input? I'm expecting 2 unary integers. And those 2 unary integers will be of the form 1 to the I, 1 to the j. So 1 to the I, 1 to the j. And then this, I need to assert that this is equal to 1 to the I plus j. So what do I really need? How many inputs do I need to express this in a set? Let's start there. If I gave you 2 unary integers in Python as inputs, and I told you write a function that decides if these 2 things are unary integers, how many inputs would you need? Let's do it. Is unary sum. So this function explicitly decides is the unary sum of a plus b equal to c. That's all this function does in Python. So what you do is just take the sum of a and b. This is pedantic, but and then you just return this as a Boolean value. Does at least this make sense? Great. Back to set notation now. What do I need to put as inputs into this set to decide whether or not something is the unary sum of 2 things?
A and B, the 2 things.
Okay, A and B, the 2 things. So, as I said, if an element is in the set, that means the answer is yes. So A and B are two arbitrary inputs. But what I'm asking is, given three things here, 1, 2, and 3, is the sum of these two unary numbers equal to C? So what else do I need to put in? I need to put in C, such that we can say that A has the form 1 to the I, A equals 1 to the I, right? B equals 1 to the J, and C equals 1 to the I plus J. Does that make sense? So now, any ABC triplet that's in this set, any ABC triplet that is in this set follows the form and is the unary sum of two numbers. Does that make sense? Questions about this? Yes? No? Thumbs up? Sideways? Where are we? Good? All right, great. Let's okay. Thanks for volunteering. You're gonna play tic-tac-toe with me. Go for it.
I'll let you.
There was a point in which you could have won earlier, I think.
I know.
It's okay. Yeah, there. Great. So we have 3 in a row here. So he's won using 1, 2, 3, 4, 5 moves, and I have 4 moves. That makes sense because we have 9 in total. And then at any point in winning the game, there's restrictions on how this board can look in a true game that's won. Right? I can't have any arbitrary, like, just saying, if I give you a tic-tac-toe board, and then I ask you, is this a valid game? You can't just look for 3 X's or 3 O's, because if the rest of the board looked like this isn't a real tic-tac-toe board. So this is one way of winning, where we had, they differ by 1. Okay, let's try another game. Go for it. You should play with the intent of winning.
Okay.
That'll help me.
Okay.
Okay. Okay.
You put my symbol.
I did.
Yeah.
This is why you need to check if you need to check if it's a valid tic-tac-toe board. Okay. Oh no, he won. Okay, that's the time. Thank you. So, what do we notice about these two tic-tac-toe boards that have actually won? Is that not only are there either 3 in a row, 3 in a column, or 3 diagonally, there's also a restriction that the number of X's and O's needs to differ by at most 1. Because any point in time where there isn't a winning game, or any point in time in which somebody is 1 step away from winning, the number of zeros and X's are equal. So restriction 1 is zeros and X's. It's actually a good way to cheat in tic-tac-toe is to see if somebody notices if I put their symbol down. Zeros and 1s differ by at most 1. Actually, I don't even think I need the at most. Okay, and then
They can be equal, right? If O wins, then they would be equal, right?
if O wins, generate the board. You're probably right, but just tell me how to do it. You may be right. So 0x, 0x.
I mean, like, if the second one, if the person who plays second wins.
If the person who plays second wins. Ah, right. That makes sense. That makes sense. So, 0x, 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 0x. Yeah, they're equal. Okay, differ by at most 1. Okay, so we have this. So that's the restriction for a valid tic-tac-toe game. And this is the restriction for a winning game. I think the problem asks us, you are given a completed tic-tac-toe board and you need to determine who won. Formulate this as a language. Great. So the way I want to do this is I want to define a language that has, let's start with this. Let's start with the language of zeros winning. Or O's winning. So my input is a tic-tac-toe board, and my output is a true or false. Again, true means I'm in the set, false means I'm not in the set. How should I encode this as a string? So I want my input to be a string. What are some of the ways I could encode an arbitrary 3x3 tic-tac-toe board as a serial string? There are many ways of doing it. This is your problem. You have a 2D input and you want to encode it as a, you have a 2D array of values and you want to encode it in a way in which it's a string and recoverable. How would you go about doing it?
You could flatten it and just put like.
Sorry, I can't hear you, sorry.
You can flatten it and just put like first row and second row.
Sure, I can flatten it and I can put the first row, second row, and third row. And I can create a symbol for like empty. So I can do that. Actually, I'm not going to use this symbol because it's too closely conflated with not putting anything. So I'll call it B for blank. So one option is if I want this to be a serial string, I just take the first row, concatenate the second row, concatenate the third row. I could also go by columns. I could take the first column, second column, third column. There are many, many ways of converting this into a string. Let's go with the representation of the input being the row major order of, wait, no. Yeah, is that row major this way? Probably. Flatten. Okay. I'll call it left to right flatten because I don't know terms. So this would be x, xb. For the first three, x, o, o, and then xb, o. Whatever this transformation is called, that's what I'm doing. So also, it's recoverable because I know the dimensions of my array are 3x3. So given the string, you can easily convert back to the tic-tac-toe board. Just took the first row, second row, and third row. So now I have some input. I have a string, W let's call it. W is made up of 3 symbols, which are 0, x, and b. Okay. Star, which means take any of these. And the restriction is that the number of zeros and ones differ by at most 1. So how can I represent that? Well, I'll define this function We'll just define this function number 0 of w, which takes w as an input and counts the number of zeros. And we'll define this function $1 of w, which counts the number of ones. So the second restriction is that the number of zeros and x's differs by at most 1. So we'll call this x. The number of zeros that I have, or O's that I have, in my string W, and the number of X's that I have, in W, they need to differ by at most 1. So I take the difference, I take the absolute value, and then I say that this is less than or equal to 1. Does this make sense? And then, one more thing. There shouldn't be a line here. And then another thing is this should be and yeah, I think that's good. Questions about that? Are we good on this? Yes? No? I'll take silence to be yes. All right, I'll move on to the second half of the lab for time. So before I do that, just quick recap. Languages are equal to sets, which are equal to problems. Problem instances are equal to strings. By problem instances, I mean if I give you an arbitrary tic-tac-toe board, that's what an instance is. So languages are sets where membership in the set means that the string is in the language, and the answer to the problem is yes. Problem instances are strings, and if the string belongs to the set or is in the language, then the answer is yes. Let's move on to part 2. One more thing. So why in the world would I want to represent problems as sets? Is there any reason you could think of? Is there any benefit to expressing a problem as a set instead of explicitly defining the problem in English? Or using some other notation? What if I'm asking questions only about binary strings? Why might I want to stick to a set notation instead of using any other arbitrary representation in English? Okay. Let's say my problem is x divisible by 2? So my set clearly, L div 2, this is a binary number, is that same string I had before. Whatever it is, it needs to end in 0. X is any Actually, this doesn't even need to binary. Let's do this. We'll make it even simpler. To really drive home the point. Okay. X is divisible by 2. L div 2 is the language x, where x is an integer, and x mod 2 equals 0. Right? I'm giving a very explicit definition of what it means to be divisible by 0. Have you guys studied finite state machines in any class before? Great. So how many states do I need to build this? So this is yes state, this is no state. How do I build an FSM that decides if it's divisible by 2? How do I decide if a number is even if I'm counting from 1? 1 is odd, 2 is even, 3 is odd, 4 is even, etc., right? So on every input, I just keep bouncing back between the two states. So on this input 0, if my input is, regardless of what my input is, first I bounce here, then I bounce here, then I bounce here, then I bounce here. If I end up in this state at the end where my answer is yes, I know I'm divisible by 2. So why would we want to represent problems as sets? Defining a problem in this way allows us to ask the question, what's the simplest machine that I can build to solve the problem? We can use sets as a way to articulate, to some degree, the expressibility of a language by a simple device. So in this state, a two-state machine would be able to decide this language and decide what things are in the language. For the tic-tac-toe board, you're going to need way more states, and I actually don't even know if it's possible to do with if it's regular, but you're clearly going to need way more states for that, right? So by expressing it in set notation, that machine is more complicated or bigger than this machine. So it allows us to say that that problem is harder from the perspective of the device that I need to solve the problem. Does that make sense? So this approach towards viewing languages as sets is really driven by asking the question, what is the simplest machine I need to solve the problem? And if I need a more complicated machine to solve one problem than another, that problem can be viewed as harder, just to motivate that. I'm only bringing this up because I don't like studying things when I don't know why I'm doing them. So, on to the second part of the lab. Recursive definitions. Problem 1. A language that contains all strings will restrict the alphabet to be 0, 1 for now. Okay, so everything is 0, 1. So all binary strings. Okay, so here's how I want to think about recursion for now. Let's say, by magic, somebody else already gave me a binary string. So somebody else has already given me a string that's a binary string x. What is the smallest thing I can add on to x to make it a new binary string? So I have some string x, and that's 0, 1, 1, 0, 0, 0. How do I construct the next biggest binary string? Use your ECE degrees. Come on. I give you this and I say I want a bigger binary string. What do you do? To which side? Great, okay. What else can I do to get the next biggest string? I could add a 0, right? I could also add these on the other side if I wanted. So somebody else has given me a binary string. The next biggest string can be constructed by taking some random string. I can build a string 1 bigger by putting either a 0 or a 1 here, right? So recursive definitions of languages, L will equal, we'll call this LA. Somebody else has already given me a binary string, X, and I know that X belongs to LA. To get the next biggest binary string, I add a 0 or a 1 to the left or right. These are my options. Or I add absolutely nothing, which is the empty string. So this is actually a redundant, overly redundant definition, but does the approach to thinking about recursion like this make sense? How can I make that smaller, by the way, this language? Do I need all 4 of these things here? So we'll take these two for example. Let's do it this way. Raise your hand if you think I need both of them. Raise your hand if you think I don't need both of them. Okay, great. Somebody tell me what to remove. Just pick two things.
The top two.
Great. Why?
You can make any string with the other.
Yes, exactly. So I removed the top two, which were originally x1, x0. So I start with, I want to make a binary string. Let's pick one of these. Let's view this from the generation perspective. So I have 0x. Now I can replace x with any of these other things. Let's pick x0. So this x gets replaced with x0. Now I have the string 0, x0. I can put an empty string, I can put 1x here. So I'm going to replace this x with 1x. And I get 0, 1, x, 0. And if I want to terminate the recursion, I just put an epsilon here. So now I get 0, 1, 0. That's my final string. So it turns out I can, if I want to add zeros and ones to any string, I can start by constructing the string from the left or the right, and I should be able to make either one. So here, I made this string using x0 and 1x. If I wanted to restrict myself to just the bottom two, which are these two, if I want to make the same string, so he claims I can get rid of these, so I could have gotten rid of this. If I want to make the same string 0, 1, 0, let's start with 0x. We'll replace it with 1x. So it becomes 0, 1x. And this x can get replaced with 0x. And then this x can get replaced with the empty string. So two of these are sufficient coverage to build any binary string. Okay, a language that holds all the strings containing the substring 0, 0, 0. So okay. So it just means I need to have 0, 0, 0 somewhere in this, right? What's the smallest string in this language? This is the smallest string. How do I get the next biggest string that's valid and in this language? Same thing. I add either zeros or ones on each side, correct? So if I have 0, 0, 0 as a substring, I can have any binary string on the left and any binary string on the right. So why don't I already use the language that I made to get binary strings to solve this problem? So some examples of strings that are example of yes instances are, okay, I have this as a substring. I start with this, I add, right? I can have it as a prefix. I can have, actually has it twice. I can have it as a suffix. So any of these work, and I can also put anything here. So what that means is this is any binary string. Any binary string. This is any binary string, and this is 0, 0, 0. Well, problem one just asked us how to make any binary string, and that's the language LA. So LB can simply just be represented as LA, a string from the language LA, where let's pick a string from the language LA, any string. Let's put 0, 0, 0 in the middle, and then let's pick any other string, and x and y can be equal, from the language LA as well. Oh, yeah. Yeah, these are in the definition. Does this make sense? Okay, moving on. A language LA that contains all palindrome strings using some arbitrary alphabet alpha. So I want to make a language that generates palindromes. Palindromes are stuff that's read forward and backwards the same. So examples of palindromes, empty string. Let's see, 0. We'll have single digit palindromes, we'll call them palindromes. 1 is a palindrome, 0, 0 is a palindrome, 1, 1 is a palindrome. What's a palindrome of size 3? 0, 1, 0, because it reads the same. 0, 0, 0. There's 1, 1, 1 is a palindrome. Another example is, I don't know, 1, 1, 1, 0, 1, 1, 1 is a palindrome. So it needs to be read the same, forward and backwards. Okay, so let's break these up into even and odd cases. So 1, 1, 0, 0, 0, 1, 1, 0, 1, 1, 1, 0, counting, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have even palindromes, and then we have odd palindromes, which are like 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1, 1, 0, 1, 1, 1, which is not an odd palindrome. 1, 2, 3, 4, 5, 6, 7. Yes, it is. Okay. So if we were to decide if a string is a palindrome, if it's even, we kind of look down the middle and then check for symmetry on both sides. We look down the middle, check for symmetry, look down the middle, check for symmetry, look down the middle, and then check these two match, these two match, these two match, and these two match. If it's odd, we basically ignore the middle element. Doesn't matter what it is. And then it just reduces to the problem of checking, are these two symmetric, are these two symmetric, are these two symmetric, are these two symmetric? So with that in mind, let's try to recursively define this. Help. So if somebody else already gave me a string that's a palindrome, we'll call it x. And that is 1, 1, 1, 0, 1, 1, 1. This is my x. What is the smallest set of characters I can add to make this a palindrome, and where should I add them? This is not a trick question. Yeah. Oh, did you raise your hand? No. Okay. Do you know the answer? 2
to the end.
2 to the end. So which 2? Okay, great. So let's put 1 on each end. Yeah, the same number, right? Or I could have put zeros on either end. So if somebody gives me a string that's already a palindrome, to generate the next biggest string, I put a 0 here and I put a 0 here. Or I put a 1 on both sides. Okay. And then how do I eventually terminate? The smallest palindrome I could make is just the empty string. And this should generate all palindromes. Any objections?